January 17, 1945, Willow Run, Michigan, 4:47 a.m. The winter air hung thick with the smell of hot rivets and machine oil. Inside the massive assembly hall, fluorescent lights buzzed overhead, casting pale illumination across a river of metal that stretched nearly a mile into the distance. The floor trembled with the synchronized rhythm of 10,000 pneumatic hammers. Every 63 minutes, another B-24 Liberator, 47,000 pounds of aluminum, steel, and American resolve rolled off the line and into the gray dawn. The workers moved like blood through veins, each one a cell in an organism that never slept, never paused, never questioned whether the impossible had already been declared impossible by every expert who had examined the blueprints. A young riveter named Dorothy McAllister, her hair wrapped in a red bandana, pressed her drill against the bomber's fuselage. The metal screamed. Sparks cascaded onto the concrete floor. She had been a school teacher 18 months ago. Now she was building the instrument that would break the back of the Third Reich. Beside her, an older man who had once assembled Fords guided a hydraulic lift carrying a Pratt & Whitney engine weighing nearly 2,000 pounds. The engine swung into position with mechanical grace. 12 minutes later, it would be bolted, wired, and tested. 12 minutes after that, the next engine would arrive. This was not a factory. This was a cathedral of production, a temple where the gods of industry had come to demonstrate what democracy looked like when it rolled up its sleeves and decided that losing was not among the available options.
The arithmetic of annihilation. In the winter of 1942, when American industrial mobilization was still finding its rhythm, German officers stationed in occupied Europe received intelligence reports that seemed designed to test their capacity for belief. The reports claimed that the American factories were preparing to build aircraft at rates that exceeded the entire Luftwaffe's annual production, not by margins of 10 or 20%, by factors of 5, 10, eventually 15. The officers read these reports with the kind of polite skepticism reserved for propaganda that insults the intelligence. Reichsmarshal Hermann Göring, when presented with similar estimates by his own intelligence staff, reportedly laughed and suggested that the Americans must be counting the bicycles in their projections. Göring had built the Luftwaffe from nothing. He understood production. He understood the limitations of steel supply, the bottlenecks in propeller manufacture, the impossibility of training sufficient workers quickly enough to meet such fantastical targets. The American claims were not merely optimistic, they were geometrically absurd. What Göring did not understand, what no European military-industrial complex could comprehend in 1942, was that America had not built an aircraft industry. America had converted an automotive industry. And that distinction contained within it a revolution in manufacturing philosophy that would rewrite the rules of modern warfare.
Henry Ford's River Rouge plant in Dearborn, Michigan, had spent 2 decades perfecting the science of mass production. Raw materials entered one end of the complex, iron ore, coal, sand, rubber, and finished automobiles emerged from the other. The plant consumed trainloads of supplies daily. It employed methods of inventory control, assembly line choreography, and quality management that existed nowhere else on Earth. When Ford's son Edsel agreed to participate in bomber production, he did not merely offer to build aircraft. He offered to reimagine aircraft as automobiles. To strip away the craft production mentality that treated each bomber as a bespoke creation and replace it with the ruthless standardization that had given America 15 million Model T Fords. The Germans built the Messerschmitt Bf 109 in workshops that resembled medieval guild halls. Master craftsmen fitted parts by hand, filed down irregularities, adjusted tolerances with the eye of experience. Each aircraft took hundreds of hours to complete. Each aircraft was, in a sense, unique. The German system produced quality. It produced fighters that could outmaneuver and outclimb nearly anything the Allies fielded in the war's early years. But the German system could not produce quantity, not in the volumes that total war demanded. By 1943, the Messerschmitt factory at Regensburg was producing at peak efficiency approximately 25 Bf 109s per week. This represented an extraordinary achievement in German eyes. The factory operated around the clock. It employed thousands. It consumed every available resource. 25 aircraft per week was considered the practical limit of possibility. That same year, Willow Run was producing 28 B-24 Liberators per day. Not per week, per day. The philosophy of the possible. The B-24 Liberator was not an elegant aircraft. It had none of the graceful lines of the B-17 Flying Fortress, none of the predatory beauty of the P-51 Mustang. It was a brick with wings, an utilitarian assemblage of flat surfaces and blunt angles designed not to inspire, but to function. The B-24 could carry more bombs farther than any other aircraft in production when it entered service. It could absorb tremendous damage and still bring its crew home. It was not built to be admired. It was built to be built.
The bomber contained 1.2 million individual parts. 500,000 rivets held its skin together. Its wingspan measured 110 feet. Its 4 engines generated 4,800 horsepower. Before Willow Run, aircraft of this complexity had been assembled in open bays, where teams of workers swarmed over stationary airframes for weeks, installing systems, running cables, testing hydraulics, making adjustments. The process was organic, flexible, and utterly incapable of scaling. Charles Sorensen, Ford's production chief, walked through a traditional aircraft factory in 1941 and experienced something between horror and revelation. He watched skilled workers drilling holes freehand, consulting hand-drawn templates, measuring twice and cutting once. He watched engineers making design modifications on the fly to accommodate parts that did not quite fit. He watched the organized chaos of craft production and understood immediately that this method would never build enough aircraft to defeat Germany.
Sorensen returned to Detroit and told Henry Ford that they could build a mile-long factory that would produce 1 bomber per hour if Ford was willing to abandon every conventional assumption about how aircraft were made. Ford, who had spent his life abandoning conventional assumptions, asked what Sorensen needed. What Sorensen needed was $475 million, 67 acres under one roof, and the freedom to tell the Army Air Corps that they could not change the B-24's design every time an engineer had a clever idea. The Army, desperate for production, agreed to freeze the design. Ford broke ground on Willow Run in April 1941. The factory became operational in September 1942. The building itself was a statement of intent. Its assembly line ran 5,500 feet from end to end, longer than 12 football fields placed side by side. The ceiling soared high enough to accommodate partially assembled bombers being lifted by overhead cranes. Raw materials entered through receiving docks at one end.
Completed bombers taxied out through enormous doors at the other end and onto an adjacent airfield, where test pilots would take them up for their first flight. The entire process, from sheet aluminum to flying aircraft, took 63 minutes once the line reached full speed. The Germans, when they learned of Willow Run's production rates through their intelligence networks, assumed the Americans were lying for propaganda purposes. No factory could produce 4-engine bombers at such rates. The assumption was logical. It was also wrong. The testimony of the defeated. Major Hans-Joachim Marcel, one of the Luftwaffe's most celebrated aces, wrote in his diary in October 1942 about the increasing numbers of American aircraft appearing in North African skies. Marcel had shot down 158 Allied aircraft by that point in the war. He was 22 years old, blonde, handsome, the poster image of Aryan invincibility that Goebbels' propaganda machine loved to celebrate. Marcel wrote with the confidence of a man who had seen his enemies and found them wanting. The American pilots are brave but poorly trained. Their aircraft are adequate but not exceptional. They come at us in formations that make them easy targets. We shoot them down. They keep coming. It does not matter how many we shoot down. More appear the next day. Marcel died 2 weeks later when his Bf-109's engine failed and he struck the tail section while bailing out. He was posthumously promoted to captain and awarded the Knight's Cross with oak leaves and swords. His diary entries were circulated among Luftwaffe officers as evidence of German fighting superiority. But buried in those entries was a recognition that German High Command chose not to acknowledge. The Americans were not trying to build better aircraft. They were building more aircraft. They were not trying to train better pilots faster than the Luftwaffe could kill them. They were training enough pilots that killing them did not matter. This represented a philosophical approach to warfare that the Wehrmacht had never encountered. German military doctrine emphasized quality at every level: better tanks, better aircraft, better trained soldiers, better tactics. The Germans won battles through superiority. They expected their enemies to compete on the same axis.
The Americans were competing on a different axis entirely. They were competing on the axis of volume, replacement, and industrial endurance. They were turning warfare into arithmetic. By 1944, the math had become undeniable even to those who did not wish to see it. Luftwaffe pilot Franz Stiegler, who would later become famous for escorting a crippled B-17 to safety rather than shooting it down, wrote after the war about the psychological impact of watching the American bomber streams. "They came every day," Stiegler recalled. "Every day the sky filled with them. We would shoot down 50, 60, sometimes 70 bombers. We would lose 10 or 15 of our own fighters. We knew we had won the battle. The next day, more bombers came, the same number as before, sometimes more, always more. Our fighters did not return. Their bombers returned. I began to understand that we were not fighting pilots. We were fighting factories, and you cannot shoot down a factory." The weight of steel. In 1943, the United States produced 85,000 aircraft. This included fighters, bombers, trainers, transports, and reconnaissance aircraft. The total weight of these aircraft exceeded 1.4 million tons of finished airframe. Germany produced 25,000 aircraft that same year. The disparity was not merely numerical, it was geological. as though America and Germany existed on different planets with different laws of physics. American production planners spoke casually about building 50,000 bombers, the way German planners spoke about building 5,000. The scale made conversation between Allied and Axis industrial managers impossible. They were discussing different realities. Consider the B-24 Liberator production across all American factories involved in the program. Willow Run produced 8,685 Liberators between 1942 and 1945. But Willow Run was only part of the story. Consolidated Aircraft in San Diego produced 6,724 Liberators. Douglas Aircraft in Tulsa produced 1,194. North American Aviation in Dallas produced 966. By the time production ceased in May 1945, American factories had delivered 18,482 B-24 Liberators to the Army Air Corps. 18,000 aircraft of one model among dozens in production simultaneously. The Boeing B-17 Flying Fortress, 12,731 produced. The Consolidated B-32 Dominator, 118 produced before the war ended. The Douglas A-20 Havoc light bomber, 7,478 produced. The North American B-25 Mitchell, 9,984 produced. The Martin B-26 Marauder, 5,288 produced. Each of these aircraft was complex, multi-engine, requiring thousands of parts and hundreds of worker hours. Each rolled off assembly lines at rates that would have seemed like science fiction in 1938. The Germans, by contrast, struggled to maintain production of their primary bomber, the Henkel H-111. Total production across all variants from 1936 to 1944, approximately 6,500 aircraft. The Junkers U-88, Germany's most versatile bomber, saw total production of roughly 15,000 units across all variants over the entire war. These were not failures of German engineering. The Henkel H-111 and U-88 were excellent aircraft, capable and reliable. German workers were skilled, German engineers brilliant, German factory managers competent. But Germany had entered a war with a craft production mentality, facing an opponent with a mass production philosophy. The gap between these approaches could not be bridged by skill or courage or national will.
Albert Speer, who became Reich Minister of Armaments and War Production in 1942, understood the mathematical impossibility of Germany's position. Speer was a genius of industrial organization. He streamlined German production, eliminated redundancies, rationalized supply chains, and pushed German armament output to heights that previously seemed impossible. Under Speer's management, German aircraft production increased from 15,000 units in 1942 to 39,000 units in 1944. This represented a triumph of organizational efficiency. It also represented a rounding error in American calculations. In 1944, the United States produced 96,000 aircraft. Speer wrote after the war in his memoir, Inside the Third Reich, about the moment he realized Germany could not win a production race against America. He had been shown photographs of Willow Run taken by German intelligence agents who had infiltrated the United States before the war. The photographs showed the assembly line stretching into the distance, bombers in various stages of completion lined up like cars in a Ford plant. "I showed these photographs to the Führer," Speer wrote. "He refused to believe they were genuine. He insisted they were propaganda fabrications. When I explained that our intelligence services had verified the photographs, he became angry and said that if they were real, then the war was already lost. I did not disagree. I said nothing." The democracy of production. What made American production possible was not superior technology or better engineers. It was democracy in its most literal economic form, the distribution of productive capacity across a broad civilian workforce rather than concentrated in the hands of a military-industrial elite. In Germany, aircraft production was controlled by a small number of established firms with close ties to the military. Messerschmitt, Focke-Wulf, Heinkel, Junkers. These companies had been building military aircraft since the 1930s. They employed skilled workers who had spent years mastering their crafts. They operated with the understanding that aircraft production was a specialized field, requiring specialized knowledge, specialized tools, and specialized facilities. The American approach was to take this specialized field and unspecialize it, to break down complex assembly into simple, repeatable tasks that could be performed by workers with minimal training, to convert the construction of a bomber from a craft requiring years of apprenticeship into a series of operations that could be learned in weeks or days. This philosophy had political implications that the Germans found troubling when they bothered to consider them. The Americans were demonstrating that ordinary citizens, school teachers and farmers and shopkeepers could be trained to build instruments of modern warfare just as effectively as trained craftsmen. This suggested that citizen armies could outproduce professional military establishments, that democratic societies could outmanufacture authoritarian ones, that the diffusion of power inherent in democracy was not a weakness, but a strength that could be mobilized for total war. The workforce at Willow Run reflected this democratic character. At peak production, the factory employed 42,000 workers. 40% were women. Many had never held industrial jobs before the war. They came from farms in rural Michigan, from small towns across the Midwest, from homes where they had been housewives or teachers or shop clerks. They came because the pay was good and because the work mattered, and because the posters told them they could do their part.
Dorothy McAllister, the riveter mentioned at the beginning of this narrative, had taught 5th grade in Ann Arbor before the war. She had never held a power tool. She had never seen a blueprint. She attended a 3-week training course where she learned to read technical diagrams, operate pneumatic equipment, and test the integrity of her rivets. Then she was assigned to a station on the assembly line where she would install the same 32 rivets on every bomber that passed her station for the next 2 years. This was the secret of American production. Not advanced technology, not superior engineering. The simple insight that complexity could be decomposed into simplicity if you were willing to reorganize the entire process around the capabilities of ordinary people rather than demanding that ordinary people develop extraordinary capabilities. German aircraft workers were expected to master entire systems, American aircraft workers were expected to master one task and perform it flawlessly 10,000 times. The German method produced craftsmen. The American method produced volume. The Germans considered this approach vulgar, mechanical, soulless. They were not entirely wrong. There was nothing elegant about standing at a station for 8 hours performing the same operation while a river of metal flowed past. But elegance was not the objective. The objective was 47,000 pounds of aluminum and steel rolling off the line every 63 minutes. The sound of overwhelming. Luftwaffe pilots who survived the war and spoke honestly about their experience described a particular moment that many of them shared. The moment they understood they were going to lose. For some, it came during the Battle of Britain, when British production kept pace with German losses. For others, it came over the skies of Germany, when the American daylight bombing campaign reached full strength. But the moment had a common quality, the recognition that numbers had become destiny. Gunther Rall, who ended the war as the third highest scoring fighter ace in history with 275 confirmed kills, described this realization in interviews decades later. Rall had been shot down 8 times, wounded multiple times, and spent significant portions of the war recovering from injuries. He was brave, skilled, and as capable as any pilot who ever flew. In 1944, Rall recalled, we would see a formation of American bombers, 200 aircraft, 300. We would attack. We would shoot down 10, 15, maybe 20. Excellent results. We would land to refuel and rearm. While we were on the ground, another formation would pass over. Then another. We would take off again, shoot down more, land, more formations. It never ended. I remember thinking, where do they get them all? How many factories do they have? How many pilots? How many aircraft can they afford to lose? The answer, which Rall and his fellow pilots learned gradually and painfully, was more than you can shoot down. The mathematics were brutal. In 1944, at the height of American bomber operations over Europe, the 8th Air Force, based in England, could dispatch 1,000 heavy bombers on a single mission. 1,000 B-17s and B-24s, each carrying 5 tons of bombs, each defended by 10.50 caliber machine guns, each part of a formation designed to provide mutual defensive fire that made attacks costly.
The Luftwaffe might destroy 5% of this force, 50 bombers shot down. This represented a catastrophic loss for the Americans. 500 men killed or captured, 50 aircraft destroyed. By any traditional measure of military exchange, a 5% loss rate was unsustainable. But it was sustainable because the Americans could replace those 50 bombers in 3 days. They could train replacement crews in 6 months. They could return to the same target next week with another 1,000 bombers. The Germans could not replace their losses. A Bf-109 pilot required 2 years of training to become combat effective. If he was shot down, those 2 years vanished. An experienced pilot was irreplaceable in any time frame that mattered. By 1944, the Luftwaffe was throwing teenagers with minimal training into combat against American bomber formations because there were no experienced pilots left to send. The sound of the war changed for German citizens on the ground. In 1940 and 1941, air raid sirens meant British bombers coming at night, dropping bombs somewhat randomly, causing damage but not destruction on an industrial scale. Citizens could shelter and survive. By 1944, air raid sirens meant American formations so large they darkened the sky, dropping bombs with precision on factories, rail yards, oil refineries, and cities. The sound of 1,000 aircraft engines could be heard from 30 miles away.
a drone that built in volume until it filled the world. German propaganda films stopped showing confident pilots climbing into their aircraft. There were no more confident pilots. Instead, the films showed civilians digging through rubble, searching for survivors, demonstrating German resilience. The narrative shifted from "we are winning" to "we are enduring." But endurance was not production. Endurance would not build more aircraft. Endurance would not replace the factories that American bombers destroyed. Endurance was what you fell back on when you had exhausted all other options.
The assembly of apocalypse. To understand what happened at Willow Run and similar factories across America requires understanding the scale of the supply chain that fed them. A B-24 Liberator contained parts manufactured in 44 states. Its engines came from Connecticut and Pennsylvania, its propellers from Ohio, its instruments from New York, its tires from Ohio, its aluminum from North Carolina, Tennessee, and Washington, its wiring from New Jersey. Managing this supply chain was itself a revolution in logistics. The Ford Motor Company created a system of procurement and scheduling that ensured parts arrived at Willow Run in the correct sequence at the correct time. Too early, and parts would pile up in warehouses, consuming space and capital. Too late, and the assembly line would stop. Workers would stand idle, production would fall. Ford treated the bomber assembly line like a river system. Raw materials flowed in at specific rates. Sub-assemblies were manufactured in feeder factories and arrived at precise intervals. The main assembly line consumed these components at a steady rate and produced finished bombers at the output. Any interruption anywhere in the system would cause the entire river to back up.
The Germans never developed logistics of this sophistication because they never needed to. German production rates were low enough that traditional procurement methods sufficed. Factories could hold larger inventories. Schedule flexibility was possible. Delays could be absorbed. The entire system operated with slack built in. American production rates were so high that slack became impossible. Everything had to arrive exactly when needed. The system was brittle by design, optimized for speed rather than resilience. But speed was what mattered. Resilience could be engineered through redundancy. Every critical component had multiple suppliers. If one factory was delayed, another could increase output. The network was fragile at the individual node level, but robust at the system level. This represented a fundamentally different philosophy of industrial organization. The Germans built robust individual units in a fragile system. The Americans built fragile individual units in a robust system. When the American bomber offensive began destroying German factories in 1943 and 1944, the German system collapsed because there were no alternatives. When American factories occasionally failed or fell behind schedule, other factories absorbed the slack and production continued. The railroad network that supplied Willow Run carried a trainload of raw materials to the factory every hour around the clock. The factory consumed 16 million pounds of aluminum per month. It used 4 million rivets per week. It employed 7,000 machine tools operated simultaneously. The electrical demand was sufficient to power a city of 500,000 people. These numbers are difficult to comprehend in human terms. They exist in a realm of abstraction where quantity transcends quality and becomes its own kind of force. But the people working at Willow Run were not abstractions. They were individuals with names and families and lives beyond the factory walls. They worked 8-hour shifts, went home to cramped apartments and hastily constructed housing developments, ate dinner, slept, and returned the next day to install the same rivets or tighten the same bolts or inspect the same welds. The monotony was crushing. The noise was deafening. The air was thick with metal dust and oil vapor. The work was dangerous. Injuries were common. Fatalities occurred. Workers organized unions and occasionally went on strike over pay and conditions. This was not a propaganda fantasy where happy laborers sang while they worked. This was industrial warfare conducted on the home front, and it ground people down even as it produced miracles of output. But the workers came to work. They performed their tasks. The bombers rolled off the line, and across the Atlantic, German cities burned. The ideology of abundance. American industrial production during World War II was not merely a technical achievement. It was an argument made in steel and aluminum about the nature of free societies. The argument went like this: a nation of free citizens, voluntarily coordinating their efforts through market mechanisms and democratic institutions, could outproduce a totalitarian state where the government controlled all economic activity and directed resources through central planning. The Germans never developed logistics of this sophistication because they never needed to. German production rates were low enough that traditional procurement methods sufficed. Factories could hold larger inventories. Schedule flexibility was possible. Delays could be absorbed. The entire system operated with slack built in. American production rates were so high that slack became impossible. Everything had to arrive exactly when needed. The system was brittle by design, optimized for speed rather than resilience. But speed was what mattered. Resilience could be engineered through redundancy. Every critical component had multiple suppliers. If one factory was delayed, another could increase output. The network was fragile at the individual node level, but robust at the system level. This represented a fundamentally different philosophy of industrial organization. The Germans built robust individual units in a fragile system. The Americans built fragile individual units in a robust system. When the American bomber offensive began destroying German factories in 1943 and 1944, the German system collapsed because there were no alternatives. When American factories occasionally failed or fell behind schedule, other factories absorbed the slack and production continued. The railroad network that supplied Willow Run carried a trainload of raw materials to the factory every hour around the clock. The factory consumed 16 million pounds of aluminum per month. It used 4 million rivets per week. It employed 7,000 machine tools operated simultaneously. The electrical demand was sufficient to power a city of 500,000 people. These numbers are difficult to comprehend in human terms. They exist in a realm of abstraction where quantity transcends quality and becomes its own kind of force. But the people working at Willow Run were not abstractions. They were individuals with names and families and lives beyond the factory walls. They worked 8-hour shifts, went home to cramped apartments and hastily constructed housing developments, ate dinner, slept, and returned the next day to install the same rivets or tighten the same bolts or inspect the same welds. The monotony was crushing. The noise was deafening. The air was thick with metal dust and oil vapor. The work was dangerous. Injuries were common. Fatalities occurred. Workers organized unions and occasionally went on strike over pay and conditions. This was not a propaganda fantasy where happy laborers sang while they worked. This was industrial warfare conducted on the home front, and it ground people down even as it produced miracles of output. But the workers came to work. They performed their tasks. The bombers rolled off the line, and across the Atlantic, German cities burned. The ideology of abundance. American industrial production during World War II was not merely a technical achievement. It was an argument made in steel and aluminum about the nature of free societies. The argument went like this: a nation of free citizens, voluntarily coordinating their efforts through market mechanisms and democratic institutions, could outproduce a totalitarian state where the government controlled all economic activity and directed resources through central planning.
This argument was counterintuitive to many observers in the 1930s. The Soviet Union's rapid industrialization under Stalin's 5-year plans had convinced many economists that centralized control was more efficient than market chaos. Germany's economic recovery under Nazi management had seemed to demonstrate that authoritarian direction could mobilize resources faster than democratic debate.
American production during the war demonstrated that these observations were wrong, or at least incomplete. Yes, centralized control could mobilize resources quickly for specific objectives, but centralized control could not match the scale, adaptability, and innovation that emerged from a decentralized system where thousands of firms competed and cooperated simultaneously. The American war effort was not directed by a single authority imposing a master plan. It was coordinated through a chaotic network of government agencies, private corporations, labor unions, and industrial associations that argued, negotiated, competed, and ultimately produced results that no central planner could have designed. When the military needed more bombers, multiple aircraft companies bid on contracts. When Ford proposed building a mile-long factory, the government evaluated the proposal alongside alternatives from Douglas, Consolidated, and Boeing. Competition forced innovation. Companies that failed to meet production targets lost contracts. Companies that exceeded expectations received more orders. The entire system operated through incentives rather than commands. This meant inefficiency at the micro level. Duplicate efforts occurred. Some factories produced components that were never used. Some designs were abandoned after resources had been committed. Money was wasted. From the perspective of a central planner, the American system was chaos. But the chaos produced abundance, and abundance won wars. German soldiers captured in 1944 and 1945 often expressed shock at the material conditions they encountered as prisoners of war. They expected the hardship of captivity. They did not expect the abundance. American POW camps fed prisoners better than German civilians ate at home. Prisoners received cigarettes, chocolate, and coffee, luxuries that had vanished from Germany years earlier. They worked in American factories and saw the machinery, the output, the casual waste of materials that would have been carefully hoarded in Germany. A German prisoner named Wolfgang Samuel wrote after the war about his experience in an American POW camp in Texas. Samuel had been a teenage Luftwaffe auxiliary before his capture. He expected to be shot. Instead, he was fed, clothed, given medical care, and assigned to work in a furniture factory. The Americans threw away things we would have repaired, Samuel wrote. A chair with a broken leg was discarded, not fixed. A torn shirt was replaced, not mended. They had so much they could afford to waste. This was when I understood why Germany lost. Not because we were not brave, not because our weapons were inferior. We lost because they had so much of everything that they could be wasteful and still have more than we did when we were careful. This abundance was not accidental. It was the result of an economic system that prioritized production over preservation, growth over stability, innovation over tradition. The American economy was designed to expand, to overflow, to produce surplus. This made it inefficient in peacetime and overwhelming in war. The B-24 Liberator became a symbol of this abundance. To German soldiers watching the bomber streams, each aircraft represented not just a weapon, but an entire industrial ecosystem that could produce it, maintain it, crew it, lose it, and replace it without meaningful impact on overall capability. The bomber was not a tool. It was a threat made physical, the threat that America could make more of everything faster than Germany could destroy it.
The transformation of perception. By 1945, even the most fanatical believers in German superiority could not deny the evidence. American production had achieved what German planners had declared impossible. The cognitive dissonance this created was profound. German military culture had been built on the belief that quality would defeat quantity, that superior training, superior tactics, and superior spirit could overcome material disadvantages. This belief had been validated in the early years of the war when smaller German forces defeated larger French and British armies through superior coordination and doctrine. But doctrine could not defeat production. Spirit could not shoot down bombers that kept coming regardless of losses. By 1945, Luftwaffe pilots were flying jets, the Me-262, the most advanced fighter aircraft in the world. They were shooting down American bombers at rates that would have been decisive in 1942. And it did not matter. The Americans built bombers faster than jets could destroy them. The mathematics had become absolute. This transformation of perception occurred at the individual level in moments of recognition. A German soldier examining a captured American truck and realizing it was built better than most German cars. A Luftwaffe pilot counting the bomber streams and understanding that each aircraft represented industrial capacity he could not begin to calculate. A factory manager in the Ruhr receiving orders to increase production by 20% with resources that had already been pushed to theoretical limits. These moments accumulated. They wore down the myth of German superiority that propaganda had built and experience had seemed to confirm. They replaced that myth with a new understanding that industrial capacity was a weapon more decisive than tanks or aircraft or soldiers. That the nation which could produce more of everything would eventually bury the nation that produced better individual items. This was a bitter realization for Germans who had been raised to believe in the superiority of German engineering, German discipline, German culture. It suggested that craftsmanship did not matter as much as they had believed, that the careful work they took pride in could be rendered irrelevant by systems that valued speed over quality, that the American approach, wasteful, crude, inelegant, nevertheless was more effective. Some rejected this realization entirely and retreated into fantasies of secret weapons and miracle technologies that would reverse the tide. Others accepted it and understood that Germany had lost the war the moment American factories converted to war production. The most perceptive understood that they had not merely lost a war, but had been confronted with evidence that their entire worldview was incomplete. German philosopher Ernst Jünger, who served in the Wehrmacht during the war, wrote in his diary about watching American bomber formations in 1944. Jünger was a combat veteran of World War I, a recipient of the Pour Mérite, Germany's highest military honor.
He was not a man easily impressed or intimidated. "The formations pass overhead daily now," Younger wrote. "They are magnificent in their terrible way, precise, mechanical, unstoppable. I find myself thinking of them not as weapons, but as arguments. Each bomber is a proof in steel that the Americans have solved some equation we did not know existed. They have determined the exact relationship between industrial capacity and military power, and they have organized their entire society to maximize that equation's output. We believed in the individual warrior, the hero, the man of superior qualities. They believe in the system, the machine, the aggregate. We are watching our philosophy be defeated by their mathematics."
The epilogue of metal. In the end, the story of American bomber production is not primarily about aircraft. It is about the nature of power in the modern world and how that power could be generated, concentrated, and applied. The Germans had organized power vertically, through hierarchy, specialization, and elite control. The Americans organized power horizontally, through distribution, standardization, and mass participation. Both approaches had virtues. The German method produced excellence. The Me-262 jet fighter was a masterpiece of engineering, years ahead of anything the Allies fielded. Individual German soldiers were often better trained and more experienced than their American counterparts. German tactics were sophisticated and flexible. But excellence could not overcome volume. The Me-262 was magnificent. Germany produced approximately 1,400 of them. The Americans produced 96,000 aircraft in 1944 alone. The arithmetic was settled before the first shot was fired. Walk through the Willow Run Plant today. It has been repurposed, subdivided, converted into warehouses and light manufacturing, and you can still feel the scale of what happened there. The building is too large to comprehend from inside. You walk, and the ceiling remains distant, the walls never seen closer. Stand in the center of what was once the assembly line, and imagine a bomber rolling past you every 63 minutes, 24 hours a day, for 3 years. Imagine the sound, the smell, the heat, the pressure to maintain pace. 42,000 people came to work here every day. Most of them were ordinary Americans with no particular expertise in aviation or manufacturing. They learned a task. They performed it. They went home. They came back the next day. For 3 years, they did this, and together they built 8,685 bombers. Those bombers carried 500,000 tons of bombs to German and Japanese targets. They destroyed factories, railroads, oil refineries, and cities. They killed hundreds of thousands of people. They ended the war years earlier than it would have ended without them. The moral calculus of strategic bombing remains contested, and probably always will be. What is not contested is that the bombers were built. They flew, they dropped their bombs, and they accomplished their strategic objective. The B-24 Liberator was not a beautiful aircraft. It was a tool, optimized for production rather than aesthetics. Its pragmatic ugliness was itself a kind of statement about American priorities. Form followed function. Beauty was a luxury. The war would be won by the side that built more tools, not the side that built more beautiful tools. Standing in that enormous building, you realize that what happened at Willow Run was not primarily an industrial achievement. It was a philosophical victory. Democracy had proven it could match and exceed totalitarianism in the one arena that totalitarianism claimed as its advantage: the ability to mobilize society for total war. The Americans had taken the German challenge, industrial production as a national capability, and had simply done it better by doing it differently. The Germans built aircraft the way they built everything: carefully,
precisely, with attention to craft. The Americans built aircraft the way they built cars. Quickly, cheaply, in overwhelming volume. Both approaches worked. One worked better. Every 63 minutes, another bomber. Every hour, another proof. Every day, another 1,000 tons of bombs over Germany. The mathematics became destiny. The factories became fate. And when the war ended, and the survivors tried to explain how it had happened, how the impossible had become routine, how bomber production had exceeded every pre-war estimate by factors that seemed like transcription errors, the answer was always the same. Americans had decided that losing was unacceptable, and they had reorganized their entire society around the proposition that industrial capacity was the weapon that mattered most.
They were correct. The factories proved it. Every 63 minutes, for 3 years, one more proof rolled off the assembly line and into the sky. The sound of those engines, multiplied by thousands, became the sound of the 20th century's central truth that in modern war, the nation that can build more will defeat the nation that can build better. That quantity, when sufficient, becomes its own quality. That democracy, properly mobilized, could outproduce tyranny not despite its distributed power structure, but because of it. This was the argument made in aluminum and steel. This was the debate settled by assembly lines. This was the verdict delivered one bomber at a time, 63 minutes apart, until the question of who would win the war became not a question of courage or tactics or spirit, but a question of arithmetic. And arithmetic does not negotiate. It simply accumulates until the weight of numbers becomes undeniable. One bomber every 63 minutes. Do that for 3 years. Add the other factories doing similar work. Calculate the total. Then ask yourself what chance Germany ever had once America decided that survival required becoming the arsenal of democracy. The answer is in the factories. The answer has always been in the factories. And the factories spoke in the language that everyone could understand. The steady, rhythmic, inexorable sound of metal being transformed into victory. One rivet at a time. One bomber at a time, one shift at a time, until the sky filled with them, until there were too many to count, until the war was over and the question had been answered forever.